binary search, what do you think about it? Like you didn't done this in your college yet, right?
No, he has
What
not
the
yet
binary
started
search
my
is.
yes.
Okay. So you know what, like whenever you are saving the data, you are storing the data. So like when you, once you are like, if we'll be taking the example of your room, right? So if you're putting the things in your room and you are not arranging it in order, right? You are not putting it on the places, right? So where
Yeah.
you want to find something, so it will be messed up. And if you want to find even a pen, so you have to go through each and everything, right? Then
Yeah.
you'll be getting. But if you have just sorted everything and you just kept your pen in the pen box only, and on the specific place the pen box is also kept, so you'll easily go in your room and you'll get it, right? So
Yeah.
when it comes to the data, so data structure we are studying about. So when it's come to the data structure, so data structure is actually we are using to organize the data, right? Organize and storing data in the sorted manner. Okay. So what you were saying, like it's not related to code. Okay, Puskal.
Yeah.
So I was just listening at the time. So like this is the thing actually. So it's like we are not using data structure. It's not, it is something how actually we are storing the data, how we'll be able to perform the operation with it, how we'll be finding the data, we'll get there are a few operations that we can perform with it, right? The searching operation, insertion, deletion, right? So these operations will efficient, okay, to
Mm.
perform like in the efficient way. If you want to perform these operations, so then you want to use the data structure, okay, so that your data will be organized in the well mannered way. Okay, so if we'll be talking about the binary search, so we can say like imagine you have a sorted list, right? So
Yeah.
it will be just normally if I have to discuss what, but first let us know what actually the binary search is. The binary search tree, as you can see, this is the example of binary search tree over here. And use the pen tab. Just give me 1 second here. Yeah. So if you'll see here, we do have the wait,
Yeah.
it's still not selected. Okay. No, it got selected. Okay. So yeah, if we'll be talking about this, this is the example, right, of the
Mm.
binary search tree. So if your data is arranged in this manner, right? So like how you will be able to find, right? You know, some of the times like few of the nodes will be connected with another one, right? If we talk about if you are storing the data, right? So some of them can be connected with each other, right? So related to you, some more informations, if you are taking some more courses, right? So your informations will be stored. It is just for example, I'm telling. So
Yeah.
the binary search tree is the data structure used in the computer science for organizing and storing the data. That definition is written only, I'm reading. So each node is a binary search. Like in the binary search tree, if you'll notice, so there'll be like, it can be one children also or two children also. It depends, right? But the main thing is, if you'll notice, the left node or right node, so the left child will always be like, you know, less, like this smaller as compared to the node, and the right side will be bigger. Can you
Mm.
notice that? Whether we are looking for three, so like left one is like one, then six, right? On the six also we do have two nodes. So four, left one is four, and then seven we do have here, right? Can you see here? We do have four,
Yeah.
like this side is the lesser one, and then for the 10 also it is following the same. And this is 13, so it is going on the left side, not on right. Okay, this is how actually we are designing the uh, binary search tree. Okay, so if I'll be taking a normal number, will you be able to do it? Like if I'll just take a normal number and we'll try to organize it. So this hierarchy structure like allows for the efficient searching, right? If you want to search something related to, you will be able to search it easily, right? If it is like a lesser or bigger, right? Then so insertion and deletion operation performing with the data structure is easy because the data, the information will be organized in well-mannered way. Okay. So if we'll take one example here, if I'll be talking about, okay, so yeah, if we'll be taking a random number for binary search, kind of like, so not for binary search, for arranging in this tree. So how actually it will be done? Okay, so if we are taking the number 4, 2, 3, 6, 5, 7, 1.
Yeah.
Okay, let me write it. It is taking time. Ha. Better than this, my mouse will work. I think that because of the internet, it is working slow. So floor 4. And if we'll be taking like 2 after this 4, 6, 8. Yeah, actually. If we do have this data, okay, and you got an objective question, kind of like just organize this data in the like that binary search tree. You want to create the binary search tree with this data. So how actually you think like you want to start working with it?
Mm.
So and if we just imagine if we
We
are
can take
going to
6
start
on
with
top.
the node 4, huh?
We can take 7 on top.
No, it's not like that.
No,
We
no,
can start
6
with
on
any
top.
node.
6 on top.
In binary, in binary, we can keep any node actually as the first node. So
Yeah.
if we are
Just
starting
the
from
left
4,
one needs to be smaller and
okay,
the right one needs to be bigger.
yeah. So what do you think? Like if we think like on the left side, we can keep 2, right? It is less than uh like 4. And if we'll be talking about 6, that is more than 4, right? So we can arrange it like that. So we can just draw it like this. So 2, we'll be talking about 2 to keep. So it will go on left, and we'll be talking about 6. So it will go on right. Right?
Yeah.
So now we just will be just going for the third node, right? So but if we'll be talking about the 2, right? Let us first work with the lefter branch if we'll be working with. So the left side will go the lesser one. So what is less than 2 here in our list right now? In this one, what is actually
1.
is the, yeah, only 1 is the that is lesser than it. And what
Yeah.
is that just bigger? We can keep the 3 over
You
here,
can
right?
take 3.
Yeah. And if we'll talk about 6, then what? What is like smaller than 6? What is left in that list now? Hmm?
Mm-hmm.
What is like lesser than? We'll take 5 here also.
You can
Maybe.
take 5.
So like
Yeah.
5. So if we like 5 will go left. I'm just increasing the size to understand it well, right? So 5, and then here this side will be just keeping the 7. So this is actually